Right, so far we have solved a system of equations by graphing. Now we're going to get into systems of inequalities. At the end of this lesson, you'll be able to solve a system of linear inequalities by graphing. Alright, so a solution to a system of linear inequalities, if you remember with inequalities we do lots of shading, so there's more than one right answer. So same thing with systems of linear inequalities, there are going to be all sorts of answers, not just one. So when we solve it, it's going to be all of the points that make both inequalities true. So we're going to do lots of testing, and again, I'm just going to put like an X and a Y because there's going to be all sorts of points that we're going to be dealing with. All right, we're going to jump right into examples. We're going to find the solutions to the systems of inequalities below, and then as we get through the answer, I'll try to explain kind of what's going on. All right, we've got y is greater than negative 2x plus, let's do plus 3, and then y is less than or equal to 2x minus 4. Alright, so the first thing I'm going to go ahead and graph the first one, and I like to on this one use lots of colors, so I'm going to use purple for this first one. I'm going to use the part without the x first, so I'm going to start at 3, and then from there, since the slope is negative 2, I'm going to go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. And when I connect it, I need to make sure that I make a dashed line because there's no equal sign underneath. So we have to remember our inequalities on this one. And then if you recall, when it's an inequality, we're going to shade one side or the other. So if you recall, we're going to test 0, 0. So let's test 0, 0 on this one. When I do that, if I plug 0 in, I end up getting 0 is bigger than negative 3. Oops, is that plus 3? Positive 3, sorry about that. Okay, so now we need to think, does the mouth eat the bigger number? No, it does not. This is a false statement. So we are not going to shade the side of the line with 0, 0. We're going to shade the other side, and it will be important that we do shade as much of it as we can. Alright, and now I'm going to switch colors. I'm going with green on the second one. Alright, so this next one, again, I'm going to start with the one that doesn't have the x in it, which was negative 4, so I'm going to start down at negative 4. And then I'm going to, since the slope is 2, I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. It's kind of getting hard to see. I'm going to connect it with a solid line because there is an equal sign, so we do get to include it in our solution. Alright, so now again we get to test 0, 0, and when we do that, if I plug 0 into both of those places, I'm going to get 0 is less than or equal to negative 4. Is the mouth eating the bigger number? Nope, so this is also false. So I'm not going to shade my green line now. I'm not going to shade the side that has 0, 0. I'm going to shade the other side. Okay, and now we need a third color, a darker color. So here we go. My darker color is going to be, where do you see both colors? Where did both colors intersect? And it's going to be in this area right here. So that's what I'm going to take. You might want to like use your pencil or something for that part. Okay, and I'm going to also just darken the boundary line. This boundary line is solid and this boundary line is dashed. So that is my answer right there. And then just like we did on the other inequalities, I'm going to put a couple that are solutions and then a couple that are not solutions. Okay, is a solution would be anything in this black area. So an example might be like 6, 2. It's for sure one. Another one that might be would be 4, 0. And then any ones that are not, anything that's not in this black area, so I'm just going to pick one way over here, which would be negative 4, 0. But I could also pick one down here, so I could pick 3, negative 4, because it's in the green, but it's not in my black area. So that's, lots of different things can be answers, so that's how you would do a problem that looks like that. Okay, let's try another one. We've got 3x plus 2y is less than 6, and y is greater than negative 1. Alright, again, we're going to go ahead and graph each one separately. I'm going to go ahead and do this one in one color. And when I do this, I do notice that I'm going to have to solve that for y. So I'm going to come down here, do a little side trip. So I'm going to subtract 3x. And I'm going to get 2y is less than 6 minus 3x. And then I remember I have to divide everything by 2. So I'm going to get y is less than 3 minus 3 halves x. Okay, I'm ready to graph it. I'm going to start at the number that doesn't have the x in it, so I'm going to start up at 3. And then I need to go down 3 over 2, down 3 over 2, down 3 2, and I'm going to make it a dashed line because there is no equal sign. Okay, and then I'm going to test 0, 0, so I'm going to come down here and put 0 and 0 in. When I do that, I get 0 is less than 3. That is a true statement, so I get to shade the side of the line that has the 0, 0 on it. Okay, and then it is time to switch color. Okay, back to my green. Right, on this one, it's a y equals line, and a y equals line I know is the y-axis is going vertically, then a y equals goes horizontally, so I'm going to go down to -1, and I'm going to draw a line straight across. Once again, there's no equal sign, so it needs to be dotted. Okay, and then from there, we get to test 0, 0. When I do that, I get 0 is greater than -1. The mouth is eating the bigger number. That is a true statement. So for the green line, I shade the side that has the 0, 0 on it. And now it's time to get out my dark color. So again, remember what I'm going to shade is where both colors intersected, which is going to be in this triangular area right here. And I am going to darken the boundaries. Both boundaries happen to be dashed lines this time. Okay, so that's what my answer would look like. And let's just come up with one that is and one that is not. Okay, so my is going to be, let's see here, anything in here I'm going to pick like -3, 3 for sure is one, and I'm going to pick one maybe down here, 3, -5. Lots of different choices we can choose from both of them. Alright, next example, I'm going to, after I fill in this number, I'm going to let you go ahead and do this one and see how you do. So let's go ahead and put a 4 in there. So please, at this point in time, pause the video, try it, and then come back and see how you did. Alright, I'm going to start up at 4. So starting up at 4, and then -5. So I'm going to go down 5 and over 2, down 5 and over 2. This is going to be a solid line because of the equal sign. And then when I test 0, 0, I get 0 is less than or equal to 4. That is a true statement. So I get to shade the side of the line that has the 0, 0 on it. I'm going to do lots of shading here. Switch my colors. Okay, green, here we go. This one I'll start down at -2. Kind of hard to see sometimes with these colors going on. I'm going to go up 1 over 2, up 1 over 2, up 1 over 2. It's going to be a dashed line because there's no equal sign. Okay, I get to test 0, 0 once again. And when I do that, I'm going to get 0 is greater than -2. Is the mouth eating the bigger number? Yes, it is. So this is also a true statement. So again, I'll shade the side that has the 0, 0 on it, and then it's time to get my dark color. And so now I get to shade the area that where those two colors intersect, which again is just in this big slice right here. And I do need to shade the boundary areas. This one is a solid line, and this one was a dashed line. Okay, and then if we do an is and an is not, an is would be -5, 0, and an is not. I'm going to come up here this time. Let's do like 4, 4 is definitely not. And we will just save example 4. We might do it together as a class. So hopefully now you know how to solve a system of inequalities by graphing.